Hello everyone, in this video I'm going to be talking about something called reflection and refraction. Now my students often get these two confused, so that's the purpose of this video, to distinguish between reflection of light and refraction of light and what those two actually refer to. And we're going to draw ray diagrams in both instances. So that's why I've put the title Reflection versus Refraction, so that you can tell which one is which. Now in this video I'm not talking about waves being either transverse or longitudinal and the difference between waves. That I'll do in another video. This is just to highlight the difference between these two terms at the top. So let's start with reflection. Light waves reflect off a surface. Now that's fairly obvious. When waves actually reflect, they obey the law of reflection. And the law of reflection states that the angle of incidence equals the angle of reflection. So we're going to explain exactly what that means. So let's take, for example, a mirror. Let's just say we draw a plane mirror here. Plane mirror, so a mirror with a flat surface. So we have a plane mirror here, not the most straight line, but still. So we have a plane mirror, and we draw a normal, and that's a line drawn at a right angle to the reflector. So our normal in this case would be something like this. So it's at 90 degrees to that plane mirror. Now, if we imagine that a light ray is coming in, so let's say it's coming in here, it's going to reflect off that plane mirror, it's going to reflect off that surface, and it should reflect something like this. Now, smooth surfaces produce strong echoes when sound waves hit them, and they can act as mirrors when light waves hit them. The waves are reflected uniformly and light can actually form images. Now in the plane or flat mirror, the image appears to be actually behind the mirror in this instance. So when we're drawing this ray diagram, we have our plane mirror here with the normal shown, and we need to label these different rays. So the one at the top here, the one that is coming in to strike the mirror, is called our incident ray. The one that is reflected off the plane mirror is the one we know as the reflected ray. So we have incident ray coming in, reflected ray coming off. Now this angle here so whilst I'm shading that part in red, that angle there, the angle between the normal and the incident wave or incident ray, that's what we call our angle of incidence. The angle of incidence is always between the incident or incoming ray and the normal. So you might be able to guess that this angle here, that I'm colouring in blue, that angle there represents the angle of reflection. The angle of refraction is always between the reflected ray and the normal. And that is how we construct a very simple ray diagram. And that is all there is to reflection. Reflection is when light waves hit off the surface and are reflected or bounced off that surface. And we notice if we looked at the angles between the normal, we'd find that the angle of incidence is equal to the angle of reflection. That's what defines a reflected wave. But what we're going to do now is separate this off and talk about refraction. Because refraction is something slightly different. Refraction is a scientific word for when light bends. So it's different to reflection in that when we reflect a light ray, we have the ray incoming and then a ray being reflected off, whereas with refraction, the actual incident ray bends in a different medium. Now, light waves change speed when they pass across the boundary between two substances with different densities, such as air and glass. So, when light rays, for example, are aimed at a block of glass, so let's draw in just a block of glass here, or even let's say this is perspex. So we have a block of perspex, because we often use that in classroom settings. We've got a block of perspex here. When the light goes from the air into that perspex, it's going to change direction. It's going to bend, and that is called refraction. And it bends because we've changed its speed. Now, refraction does not happen if it crosses the boundary at an angle of 90 degrees, or the normal. So the normal on this perspex box would be, as I've drawn here, and if light rays were to enter in that very direction, so in the direction of the normal, so I'll just put an arrowhead to represent that here, if light rays were to enter in that direction, then you wouldn't see refraction. The light would be slowed, but it would leave the block in the same direction as it entered. But if the light ray were to enter at an angle, something like this perhaps, if the light ray were to enter at an angle, you'd find that the light would be bent towards the normal, a bit like so. And upon leaving that material, because it's going from perspex to air, because again it's a different density, you'd find that it would bend away even further again. So the light ray comes in at an angle, the refracted ray within the perspex would bend towards the normal, and then as the ray leaves the perspex and goes into the air, because the two of a different density, the direction is once again changed and it will deflect away from the normal. It refracts or bends away from the normal. So what we have now, once again, is our incident ray. And this here, I'll shade in red, that is at angle of incidence. We have this ray inside the perspex, and this would be our refracted ray, so not our reflected ray this time, our refracted ray. And now if we look at this angle here that I just shaded in blue, that there is now our angle of refraction. Now, as the ray goes into the perspex from the air, it's bent towards the normal, so what we should see is that the angle of refraction is less than the angle of incidence. Now that is key, because in reflection, the angle of incidence was the same as the angle of reflection. But in refraction, what we see is that the angle of incidence is actually greater than the angle of refraction, because that refracted ray is bent towards the normal. And that fundamentally is the difference between the two. So reflection is simply just when the light rays are reflected off the plane surface, and refraction is when those light rays are simply just bent and forced to change their direction. And that occurs when they pass into a material which has a different density than the one that they've come from. So at the boundary between substances with different densities, such as air and glass or air and perspex, they change direction and ultimately change speed because of it. Okay, hope all that helps.